Unfortunately, Alex from deltaVision couldn't be with us today, but he's prepared a little pitch on video. So can we launch the video, please?
Good afternoon, everybody. My name is Alex, and I am a rocket engineer. And today, first of all, I want to show my admiration to all the female beings outside here. You are awesome, and we are happy. We are lucky to have you around. So happy Women's Day to all of you, especially to my mama. So today I speak in the name of deltaVision, Fluid Control and Aerospace, a company of around 7 months old age, and which I had as co-founder and CEO. So the origin of our company is the contribution of the founders within European space programs for a decade, more or less, where we got a deep understanding of problems and solutions in particularly cryogenic, it means deeply cold, fluid control systems. This knowledge, being previously tailored to a niche application, we happily observed that this technology rises quickly in demand. So, for example, in the new space domain and also in the H2 aeronautics domain, which we consider our core markets. On top, there's also some synergies to this technology in the hydrogen mobility domain, for example, for long distance, heavy duty applications. So this the hydrogen mobility sector, we consider as an expansion market for our company. So what I am talking about basically. So if you look on a hydrogen airplane or a cryogenic truck or a rocket stage, a classic rocket stage, here the lower stage of this micro launcher, you find similarities in the architecture. You always have any kind of a fuel tank and any kind of a rocket and any kind of an engine and a system that connects the engine and the tank. And this is called fuel distribution system, or in aerospace, mainly functional propulsive system. Such a functional propulsive system is quite complex and consists of many parts depicted on the left-hand side here. Those are mainly valves, which are marked blue, but also other elements like marked in black, like filters, bellows, sensors, and anything else. So such a functional propulsive system accounts to 25 to 50% of total propulsion system costs. So we are talking real money here and real potential for improvement. But at the same time, due to this huge rise in demand for such elements of a functional propulsive system, we face a lack of suppliers in this domain. This was a hypothesis for us to found a company, and this is meanwhile confirmed by many customers. So this lack of suppliers leads automatically to long production times, to high pricing, and also to limited innovation. Exactly this problem we want to solve with deltaVision. We intend to become a vertically integrated supplier to provide high-quality cryogenic fluid control solutions to our customers. So our current product baseline is the following. All the products you see on the left-hand side here are under development and or production upon customer request. Our main product family at the moment are the solenoid valves, which we have already available in several designs and which we also do testing with. Then in the middle, we have the brushless DC motor regulation valves, which are a fantastic piece of technology because you can adjust the flow inside your system very precisely, below 1% accuracy. And this is quite an efficient tool if you need to streamline the thrust, for example, of your system to perform landing maneuvers, or if you want to take off an airplane and need increased thrust. Respectively to the both product groups that I just described, we also have the motor controller technology in development to control the BLC regulation valves. And also we develop health monitoring technology and predictive maintenance technology to clearly understand the status of your product and also to predict the maintenance intervals to save costs in the end. So our USP is that we can offer basically any product for any application within our domain. So up to very high pressures of 1000 bar, down to 4K, also for vacuum radiation conditions, with all media and in many sizes. So please don't hesitate to request anything. On the right-hand side, you see a wonderful picture of some parts just being produced for a solenoid valve. Okay, and this is our daily business. So what we do is basically we test frozen valves. What you see on the picture here is a solenoid valve that we designed, which is seen on the bottom of this picture. And it just came out of a liquid nitrogen dewar. It was cooled down to around minus 200 degrees Celsius, so very low temperature, and tested with helium. So this is our core business, and we need to say that the performance of this product was quite good, quite in line to the expectations. Just a little bit of optimization is required, and we will have a final design that we're quite satisfied with. The next steps with such a solenoid valve is going to be the verification under real media conditions. We focus on liquid hydrogen testing by mid of this year. So by mid of this year, we will have a first product family applicable or usable in liquid hydrogen conditions and also verified it. Okay, and this was just one single product, but of course we have huge plans. What you see here on the screen is our main product family roadmap. It's progressing towards a future from left up to bottom right. And all of these pictures, they represent, visualize a point in time where we achieve a test campaign that is intended to lead to a TRL 5 or 6 status of this technology, of the single product. So the solenoid valves are already short. We have them under testing, and we'll also deliver some soon to a customer. On top of that, we develop and intend to test the health monitoring technology in liquid hydrogen conditions by mid of this year. Also, some of those solenoid valves we are going to combine to bang pressure regulator systems, where we also develop controller technology for, which is quite interesting technology because it's very reactive and could be used in many applications. So the bottom line of e-motor regulation valves, I already introduced to you the first product that we currently develop, including the controller. So this will be available in end of this year, like in October, maybe a bit earlier in September of this year. So then the next line is cryogenic space by BLDC motors. The knowledge that we will gain on the development on the motor-driven regulation valves, we will transfer into our own product families of BLDC motors. We start with a lower power class in a range of up to 5 kilowatt, which is already usable for quite a lot of applications. And then we evolve this product family towards higher power classes, above 5 kilowatt, up to X kilowatt. We need to decide on that. So in the first applications for this self-made BLDC motors are going to be an e-pump product that we develop for a 2 kilowatt class application, which shall be available, shall be tested by mid of 24, and which is the baseline for further evolution of e-pump products that we intend to have available by mid of 2025. This will be a 20 kilowatt class cryogenic e-pump. So I am convinced that with such a product portfolio, we can cover the majority of fluid control applications for H2 aviation and for any liquid propulsive spacecraft, and also in further domains as hydrogen mobility. And the cryogenic space-rated BLDC motors will help us to establish a sales channel also regarding orbital infrastructures and many other applications that are not directly linked to propulsion. Okay, so we work with 3D Experience to achieve our product portfolio. On the right-hand side, we see a quick depiction of the workflow. So we do mainly flow analysis, CFD. This I do myself as well. Electromagnetic structural analysis, and of course CAD for the digital twins. And you see on the top picture like the digital twin realized in a real product. On the bottom right, you see our test bench designed in 3D Experience, CATIA, and which is the digital twin of of my co-founder Dennis on the right-hand side, obviously. So the software in general is a cloud-based solution with local native installation. It has a very smoothly integrated workflow and integrated PDM data tool and further tools, which is quite sophisticated if you learn to use them. And a very good opportunity is the possibility for direct collaboration or at least data exchange with shared workspaces, so with other users of 3D experience. So, for example, we do it with one of our customers. We do direct data exchange of our product over this interface. So we participate in a startup program from 3D Experience because we are supported by Technical University Aerospace Venture Labs, and this is like a partner for 3D Experience. We received a 24 months tailored license package for free, and this is amazing, including some cloud computing token, which gives you additional power for computations, and support and training on requests. And we did some requests already. It's indeed quite helpful. Same counts for the access to the 3D Experience Lab and also some mentoring. So, for example, I got some marketing mentoring offered by 3D Experience, which I am very grateful for. Altogether, 3D Experience allows us to go fast. And this is the major argument. So for us, it's indeed a brilliant match to build our product portfolio. On the next slide, you will see an insight on the overall workflow in 3D Experience. This is a simplified version of one of our products, and you will now see the workflow in between CAD and CFD and drafting activities. So right now we define the volume that you want to discretize for the FEM CFD analysis. You see there's already an inlet and outlet defined, so we can continue with some boundary conditions, with velocity definitions, and with pressure outlet definitions, for example. Then adjust the solver to what it needs, and here we have already some streamline results directly integrated into the model, which is looks really good, and so a lot of fun to do. And here we do a drawing of one specific component of the inlet of the valve, and you see the workflow to create the drawing. I mean, this is quite clear to all of you. What maybe is most interesting about it, in between them, the CAD and CFD, you hardly recognize any change in the, let's say, user experience. So it looks all the same. All the maneuvers, all the commands are located similarly, and you can quickly navigate. So you don't get the feeling using different tools. So, and this is a really strong advantage. And as well, the whole usage is, how to say, very intuitive. So even with CAD beginners, you can quickly, and this is really an asset for a startup, you can quickly teach them to do CFD analysis on, let's say, medium complex problems. Okay, back to our company. Just a short summary on deltaVision that you keep us in mind. We were founded 7 months ago, on 26th of July 2022. We are 3 co-founders with technical but complementary backgrounds in electronics and operations, in system engineering and also in design, which is quite a good mix so far. And we are currently in a pre-seed phase. We signed 9 employees already, and so it corresponds to around 7 FTE working for our company from April 23. And we have 5 paying customers. Some of them are given on the right-hand side, and I am very happy that some of them are also here today in the audience. So thanks again for all the trust and good collaboration. The company status you see on the right-hand side. We signed already some of our first contracts, and are working on hardware delivery, which is approaching very quickly. So in April, the first hardware delivery is going to take place. Altogether, I expect something like 1 million in revenues by the end of this year, and to be in a team of 15 hired employees. So this is my prediction. In parallel, we are looking for an angel investment. So we are closing the round in April. And the more important even is preparation of the seed investment that we envisage in Q1 24. So there's still some room. Please get in touch with me. I will be happy to discuss common ideas and opportunities. And maybe, an advice from me to all young or mid-aged people out there that are interested in creating a new space startup. Trust me, it's not as hard as you think. So give it a try. Okay, so altogether, we are convinced at deltaVision that the future is fluid, but we can control it. Thank you very much. And just note down my contact details for any case. Bye-bye.
Okay. Thank you, Alex. It was probably a little bit longer than expected, but thank you, Alexandre.